Welcome to Reese's Pieces Math Mnemonics. Today's lesson is going to teach you a handy trig trick that's going to help make trigonometry fast and easy. For this lesson though, you do already have to have a background in trigonometry and have studied the unit circle. But this would be great for an algebra class, precalculus, and calculus. So if you're in one of those subjects, this could be helpful. Okay, first we're going to review the 6 basic trig functions, and I'm going to give you a few memory devices for these. So if you've already studied trigonometry, you know there's 6 trig functions. Cosine and sine are the 2 main ones, and all the other ones can be rewritten in terms of cosine and sine. So when you're relating cosine, sine, and trig things to x and y, cosine is equal to x, sine is equal to y. I think alphabetical. C comes before s, x comes before y. So there you go there. One of my favorite memory devices for this is for tangent. Obviously tangent's actually spelled T-A-N-G-E-N-T, but the abbreviation we use, the 3 letters, is T-A-N, so I think of tanning. So if somebody tans too much or does that spray orange tan on their skin, you can say fake tans are sick, like gross. So if you think fake tans are sick, think of tangent is sine over cosine, S-I over C, sick. So fake tans are sick, sine over cosine. Likewise, let's jump down to here, cotangent. Cotangent is the reciprocal of tangent, so it's actually the opposite, so cosine over sine. But this memory device is, cotangent's abbreviation is COT, which looks like cot, and if you've heard of a cot, that's a bed you can sleep in. So cots are cozy. So cotangent, cots are cosine, cosine over sine. Now secant and cosecant, those are both related to sine and cosine, but it's 1 over them. So secant is 1 over x technically, or actually going by the definitions, we're going to say secant is 1 over cosine. So S for secant, C for cosine. Think of opposite. And then cosecant is 1 over sine. This starts with a C, that's an S. So C and S are opposite, or here's another memory device here. Chips and salsa. You can't have salsa without chips. You can't have chips without salsa. So C and S, S and C. So basically, again, looking at all 6 of these, 2 main ones, cosine and sine, all the other ones can be rewritten in terms of cosine and sine. Okay, the next thing we're going to get to is now the hand trick. I will do some examples on the board, but for right now, let me actually grab a pen. I usually do this when I'm teaching my students. I grab one of my dry erase pens and I draw a big 2 on the palm of my left hand so that they can see it. So if you're at home and you want to draw a 2 on your hand, something that can be erased or washed off, go ahead and do that. So the hand trick is this. Basically, think of like the first quadrant. Your left hand, if you folded these, them would kind of fit in the first quadrant. Like here's the x-axis, here's the y-axis. And each finger represents one of the angle measures in the unit circle. So you can see here. So 0, 30, 45 is the middle finger, 60, and 90 is your thumb. Later we'll extend it around other parts, but we're going to start with the first quadrant. So you always have to use your left hand. The idea is, whatever you're trying to find, you fold that finger down. So let's say we're doing cosine of 60. So 60 is your pointer finger, as you can see on this picture. So hold out your left hand and do this too for practice. So fold down that finger. Now above the finger is the cosine and below is sine. And I tell my students, think of like how you read a book. You read a book from the top of the page to the bottom. So alphabetically, C, S, cosine on top, sine on the bottom, and here's the rule down here. You fold down the finger and then you count the number of fingers above and you put that under a square root. So if I'm doing cosine of 60, there's only 1 finger above, so root 1 over 2, obviously root 1 is 1, so that's 1/2. Here's where your background of trigonometry comes in. You should know from the unit circle there's only certain fractions, 1/2, root 3 over 2, root 2 over 2, and then you have 0 and 1. So there's not like an infinite number of fractions, there's a certain number, and these are 2 of them. So now let's do sine of 60. So it's the same finger folded down. Sine is the number of fingers below, 1, 2, 3, and you put that under a square root and put it over 2. So the 2 on the hand, on the palm of your hand, is you're always going to be dividing by that, so that's where this comes from and this comes from. So that's just one example. I'll do some more on the board, but that is the idea. And if you did it for something else, you could, if it's 30 degrees, you fold down that finger, or 45, you fold down your middle finger. If it's 90, you fold down your thumb. So there's the introduction. Now, I want to also teach you tangent before we switch to the whiteboard. So tangent is a little different. You're not going to have this 2 anymore. So going back to the idea of tanning, if you were to go outside and lay in the sun and get tan, look at the palms of your hands for a second. The palm of your hands should look a little different skin tone than like your arm and the back of your hand. So if you were going to lay in the sun, you wouldn't like hold your palms up to the sun. You'd probably turn it over and get that even tan on your hand and arms. So when you want to find tan, flip your hand. So let's say, let me start with it. Let's say we're finding tangent of 0. You still start out with your hand like this and you find the 0 finger, which would be the pinky. So I fold that down first, and then I want to find tan, flip my hand. And that's what you see right here. Now for tangent, cotangent, these are different than sine and cosine. It's not, you don't see the 2 anymore. So you do, for tangent, the number of fingers above under a square root divided by the number of fingers below over a square root. So notice I have square root of 0, because there's no fingers above there, over 1, 2, 3, 4, the square root of 4, which ends up being 0 over 2, which is obviously 0. Now some of you might be thinking, well, at 0 degrees in the unit circle, I already knew that was 0. That's fine. I'm just showing you the hand trick can work. Same idea for cotangent. Let's say I'm doing the same degree, so 0. Cotangent is going to be the opposite of tangent, so you start below and you put it over the above. So I have 4 fingers, so root 4 over no fingers above root 0, and that's 2 over 0, which is undefined. So there is a big difference. If it's 0 on top in the numerator, that's 0, but 0 in the denominator is bad. That's an undefined fraction, so that's undefined. And again, if you've studied trigonometry, you know there's certain values on the unit circle that are undefined. All right, let's practice some problems using the hand trick. So we're going to start out with example 1, cosine of pi over 3. Here's another thing I want to tell you. This is radian measure. On the previous slide I showed you degrees, but in trigonometry you have to know the relationship of those. So basically, another memory device I have is when you have radian measure with pi, if it's a 3 in the denominator, that is a 60-degree reference angle. Just to give you a quick idea what I'm talking about, if it's pi over 360, it's kind of like there. And a lot of you probably learned how to draw a little triangle in the unit circle and figured out that takes longer, and you can do that. Remember, this is a handy trig trick to save time. So pi over 3 is 60, so I hold out my hand, 0, 30, 45, 60. So you at home, fold down your your pointer finger, and you have a 2 on the palm of your hand. So what I do is, cosine is above, sine is below, C on top, S on the bottom. I only see my thumb, 1 finger, so it's root 1 over the 2. You're always putting it over 2. Well, the square root of 1 is just 1, so it's 1/2. When you get good at this, I've done this for years now, as soon as I fold the finger down, I see 1, I just know 1/2. As soon as I see 3, I think root 3 over 2. Because there's only certain fractions, again, in trigonometry. Just to remind you, it's either 1/2, root 3 over 2, or root 2 over 2. Those are the main fractions that you work with trig. So let's try this one with sine. It's the same radian measure, so that's 60. But remember, sine is below, and I see 3 fingers, so root 3 over 2. So just compare those two. And sine and cosine, when one of them's 1/2, the other one's root 3 over 2, and vice versa. Let's do a different angle measure. Let's do cosine pi over 4. So cosine pi over 4, now, when you have a 4 in the denominator, that makes a 45-degree angle. So another memory device is when it's a 3, it makes 60. So 3 and 6 are opposite. If there was a 6 on the bottom, it would be a 30-degree. But when it's a 4, it's actually 45, so the 4s match. So this is a 45. So if you're holding out your hand, you fold your middle finger down. And cosine and sine are going to be the same because there's 2 fingers above, 2 fingers above, 2 fingers below. So it really doesn't matter which one, but cosine would be 2 fingers, so root 2 over 2. If it was sine of pi over 4, it would be the same answer. Now when you get to different quadrants, you have to be careful with the positive and negatives, which we'll talk about soon. Sine of pi over 2. Now let's look at this right here. In the unit circle, I always tell my students there's only 2 places on the unit circle where there's a 2 in the denominator. At 90 degrees up here, pi over 2, and down here at the bottom, 3 pi over 2. So So pi over 2, this is a 90 degree. It's at the top. So if I was doing the hand trick, 90 is your thumb. So if I fold the thumb down and I'm doing sine, sine is the number of fingers below. 1, 2, 3, 4. So root 4 over the 2, which is 2 over 2, which is 1. Which should make sense. Think back to the unit circle. The ordered pairs you have, the one at the top is 0, 1. And remember, cosine is x and sine is y, so sine is the y value, up at 90 would be positive 1. I'm just showing you the hand trick can work for that too. You could also do it that way. Now, here's where you have to think a little bit more when we get into secant and cosecant. Don't forget, secant is 1 over cosine, chips and salsa, salsa and chips, C and S, and cosecant is 1 over sine, chips and salsa, S and C, C and S, opposite. So I'm seeing this and I'm thinking, okay, cosecant is 1 over sine, so I'm going to focus on what I know about sine for the hand trick. So pi over 6, again, I'm throwing a lot of memory devices at you, but you can always pause and rewind this. 6 makes a 30-degree reference angle. So on your hand, you go to 30 degrees, which is the ring finger. So I fold that one down, and I'm thinking about sine. So sine is below. I only see one finger, so that's root 1 over 2. But remember, we're doing cosecant, so it's 1 over whatever sine is, and this is 1/2. So again, let me step back. It's 30 degrees. Sine, so sine is root 1 over 2, which is 1/2, but that's on the bottom. And then you can use my other memory device of, hey, I'm dividing by fraction. Can you divide it? Don't even try it. You got to flip it around and multiply it. So it's 1 times 2 over 1. You can do that in your head. That's fine. This answer is just 2. Let's try another one. Again, if you need to pause, rewind, do that problem again, go for it. Secant, again, chips and salsa. Secant's 1 over cosine. So I'm really focusing on what is cosine. And it's 5 pi over 6. Ooh, now we're going around the unit circle, not just first quadrant. However, as soon as you see that 6 in the bottom, you should think 30-degree reference angle, which means I can hold out, let's try to stand like this. I can hold out my hand and I can fold down to 30 degrees. Again, 0, 30, 45, 60, 90. Those are the only ones you have to worry about. So I fold that finger down. I know it's cosine, but it's going to be 1 over. So what is cosine? Cosine's above, so cosine on top, sine on the bottom. 1, 2, 3, so root 3 over 2. But we do need to be careful here. What quadrant are we in? 5 pi over 6 is quadrant 2. I'll give a mini little lesson on this because I do think this is important. When you're with the unit circle, obviously quadrant 1 is right here, 2, 3, and 4. Halfway around the circle is 1 pi. A full circle is 2 pi. So if you're anything less than 1 pi, like 5 pi over 6, you're going to be in the second quadrant. Because think, if it was 6 over 6, that would be 1 pi. Anything slightly bigger than 1 pi, like 7 pi over 6, that's going to be in the third quadrant. So just so you know, the radian measures in the second quadrant, the top numerator is always 1 less than the denominator. So like 5 pi over 6, 2 pi over 3, 3 pi over 4. So once you know it's quadrant 2, why is that important? Well, we need to know the signs. So this is positive, positive, negative, positive, negative, negative, and then positive, negative. And that makes a big difference because if I'm doing cosine, and remember cosine alphabetically is the x value, cosine comes first, sine comes second. Well, cosine's negative, and that's negative. Now I have to do a little more work. Can you divide it? Don't even try it. You've got to flip it around and multiply it. So look at what I'm doing. I'm doing 1 times, flip that. Basically, it's just flipping that. And I get negative 2 over root 3. Now, any math teacher probably would not like you to leave that. Remember rationalizing the denominator. So times by root 3. I'm running out of room, but I hope you can see this. And now we move the square root of 3 to the top. So negative 2 root 3 over 3. So they can get messier like that. Sometimes they can be quick and easy, but I have a few more examples and then we're going to be done. So I wanted to do one more that's not in the first quadrant and then a couple of tangent, cotangent. So stick with me. Here we go. Sine 5 pi over 3. I see the 3 on the bottom. Immediately I think 60 degrees. So if I hold up my hand, 0, 30, 45, 60, and it's sine, so that would be below cosine, sine, 1, 2, 3 over 2. So it's got to be root 3 over 2. Now the question is, what quadrant are we in? I didn't talk about this yet today, so I might as well do it. Here we go. Remember I talked about if it's a little less than 1 pi, it's second quadrant, a little bigger than 1 pi there, but what about if it's almost 2 pi? If that was a 6 pi over 3 would be 2 pi. That's when you're down here in the fourth quadrant. This is quadrant 4 because it's just one less on top from what would make it 2 pi. So if it was 6 pi over 3, it would be 2 pi. So this is quadrant 4, and those signs are positive, negative, because you're going to the right on the x-axis, and then you're going down on the y. So positive, negative. Remind yourself, what is sine? Sine is the y value, because cosine's x, sine is y. Oh, so the y value is negative, so this answer is negative. So that's kind of how you can use the hand trick and go all the way around the unit circle besides just the first quadrant. Okay, now again, tangent, cotangent are the exceptions to what I was just doing, but let's review. When you want to find tan, flip your hand. So pi over 3 is immediately, I think, 60. So hold out your hand, fold down the 60-degree finger, which is your pointer finger. But you want to find tan, flip your hand. So now I don't see that 2. That 2 is not involved. I just say, how many fingers above, how many below? So 1, 2, 3. So put a square root over that. Square root of 3 divided by square root of 1. How many fingers below? And then obviously that is just going to be root 3 over 1, which is root 3. Okay, watch. Same radian measure, pi over 3, but now it's cotangent. So I'm still looking at the same situation, but cotangent is the number of fingers below. So root 1 over root 3, which would be 1 over 3. And remember, yep, your math teacher's not going to want you to leave it like that, so you've got to rationalize the denominator. So I'm multiplying the top and bottom by root 3, which would give me root 3 over 3. Now again, if you've studied trigonometry in the unit circle, this should look familiar. There are some fractions that come out to be like that. Some are just root 3. But there's 2 examples with tangent and cotangent. Let's do one more tangent and then we're done for today. Here we go. I see a 4 on the bottom. Think 45. With your hand, that would be the middle finger that chops it in half, 45 degrees, cuts 90 in half. Want to find tan or cotan, flip your hand. And now we got to think, oh, 3 pi over 4. 3 pi over 4 is quadrant 2, what I taught you earlier. It's not quite 1 pi, so it's like not quite half a circle. So quadrant 2 is negative, positive, so different signs. Now watch with the hand trick for tangent. We hadn't done one like this yet today. It's the square root of the top number of fingers divided by the square root of the bottom. But you know what? Those are the same. So it's root 2 over root 2, which you can do in your head, which is 1. And a lot of you probably already know that tangent pi over 4 is 1. So tangent 3 pi over 4 is 1. But wait a minute. Let's go back to this. Remember, tangent, fake tans are sick sine over cosine. So it'd be positive divided by negative, so my answer has to be negative. So that's how you can adjust for the signs. Thank you very much, and I'll see you in my next video.